Hello, welcome to a new video. Today we're just going to solve this problem called permutation medium problem LeetCode number 46. I did have a lot of problems with this because backtracking is my current weak spot I'm currently trying to train. So this is my third backtracking problem. I mean, the first two ones that I did a couple days ago were just ones that I just studied. I didn't really like make a video on it because I didn't really get it. But now I'm starting to really get like the pattern of backtracking, where we just take this choice and then go through with the other choices with like recursion. And then once you do the recursion, you should get the answer, right? And so once you have the answer with recursion, you say, okay, I'm gonna remove what I did before the recursion. So yeah, that's kind of what I'm getting from it. And so yeah, this is fine. So I'll just go through some. I'll go through like some like the pattern. But since I'm just learning this, I don't really know what I'm talking about. But I'm just explaining it in my words, so I can understand it. And like, when I talk about something out loud and maybe like actually like regurgitate what I studied, trying to present it, I find that it really helps me with actually learning. So that's what I'm doing right now. So let's just go through my problem solving process, anyways. So let's read the problem. So given an array nums of distinct integers, return all the possible permutations. You can return the answer in any order. So our input is just int array of nums, and int array named nums. I mean, then our output is just it doesn't say, but return all possible permutations. I would ask the interviewer, so is this like a 2D list or something? And then they'll be like, sure, because it is in the example. So 2D list of int sublists named result, I guess. And then let's go ask some questions, why not, right? So can input be empty? Let's ask that question. No, it can't be empty. No. So okay. That's the only question I really need. So and then we can take some notes. So what is a permutation? We can just search it. I don't know what a permutation is. Permutation is just all possible combinations. All possible combinations. So that means all unique too. Um, so yeah, let's go through some examples. Let's just do make it really basic. So let's say we have let's say our input list is basically our input list is 1 and 2. Let's make it bigger though. Let's say our input list is 1 and 2, right? So that means that all the possible permutations are the combinations of those. So first combo would just be 1 and 2, right? And then the second combo would be 2 and 1, right? So basically swip swapping. So yeah, it's kind of it. We'll possibly go into deeper depth once we do like 1 and 3, 1, 2, and 3, because that'll be like how many combinations? That'll be like one, or like one. Because so if there's like length of 3, then for the first place we can do 2, 3, and for second place we can do 2, then for the last one we can do 1. So 3 times 2 times 1 is equal to 6. So there's 6 possible combinations that we could do with 1, 2, and 3, but we'll get that on later on. So I guess that's example 1 and 2. Um, you can imagine the output of example 2 is just this, right? So we went through some examples. So let's go ahead and go through some matching, right? So what can we do? Well, for my previous problems in depth and not depth research, but in backtracking, we did depth research. And then we had like a have seen type of thing going on. Um, did we? I'm not sure. I think that's like graphs. But it's the same thing. I guess you can apply the have seen here in this case, where if we've seen two already, then we don't use that. But for this, we're only use that for search. But I know in other programming languages, in this types of problems, you do have seen and stuff like that. Like a bool of like a list of bools to determine if you can use this number or not, right? But in Python, we just have the in operator, so I guess we can say the in operator. And then that's pretty much it. So yeah, we also have a result list, and then we're gonna have like a cur and cur to keep track of cur permutation. Okay. And then to plan, yeah, the planning part is really weird because I feel like you can't really plan unless you know already like what to do for permutations in general. So let's just go through our example. Let's say we have 1 and 2 and 3, right? You start off, right? Let's make this smaller. You start off, right? Remember how I said we can start off with three options for the first one. So 3 times 2 times 1, because there's three values here. So there can only be three possibilities for the first value, and then 2 for the second, and 1 for the last one. So basically, we can start off like this. It's going to be like this: 1, 2, and 3. So these are our first three. And then for the second one, we could be like 1 and 2, 1 and 2, and then like 1 and 3. And then for the third one, it's either 1, 2, and 3. It's either no, it has to be 1, 2, 3, and then for this one it has to be 1, 3, 2. Right? So how do we code this? Because if we already did the operation for this one, for just one, then it'll be the same operation for two and three. Yeah. So we just need to code how this works, right? How does this work? Well, we can just do that first search. So that first search, we have to initialize our resulting list first, and then we have to do that first search, right? We'll just take incur. And so, each time we do that first search, right? We have to check what we're given. So let's just say that we're given 1, 2, and 3. So if the length of cur is equal to the length of nums, which is our input list, so nums at, yeah, that makes sense because nums is still 3. Yeah. Then we're going to append. So res dot append cur, and then we're going to just return, right? But if that's not the case, here's what we're gonna do, right? So initially, what we're given in cur, so it's just an empty list because that's how we're gonna start this initially. Because we can't just say we're gonna start that for search with just one. That's not how it's gonna be. Well, you can do that with sometimes, depending on the problem. I think last problem I did with we started that for search with a number inside the input list for that for search. But in this case, it's going to be empty because what we're going to do is, so once we're done with the one, right? Once we're done with one, we're going to be like, okay, so remove one, then go to two, and then do the same thing with two that we just did with one. So we're gonna start with an empty list, and so if that's the case where we're just doing our depth first search initially or doing our backtracking. First thing to start with backtracking, the thing is we gotta do for possibilities. For possibilities in input, we say if possible, do possible, do it, then backtrack, and then remove the it. That's very weird how I worded it, but that's kind of what we did, right? So let's just go run through the pseudocode. So for possibilities and input, right? So we start off at 1. So we start off at 1, correct? So start off at 1. No, we start off at 0. Okay. So we start off at 0. No, we start off at like an empty list. Okay. And then we're like, okay, so for possibilities in the input, right? So there's 1 and 2 and 3. So do it. Do the first possibility. Do first possible. So the first possible is 1, right? First possible is 1. Then we do backtracking. Okay. So with backtracking, what we do is we just call depth first search again. So call DFS. Call DFS again. So call DFS with possible. And then what happens is that, okay, so for possibilities and input, if possible. So if possible, so we already did 1, so that's already possible. So now we got to move on to 2 and 3, right? So the first possible is 2, so 2. Okay. And then we did the first possible, so now we do depth first search with 1 and 2. Okay. And so then we go through this for loop again. So 4 possibilities in input. We already did 1 and 2. If possible, so we already did 1 and 2, so now to go to 3. So we append 3. So we add 3. And then once we add 3, we call that first search again. And then once we hit this, we're gonna append our current to our resulting list. So this 1 and 2 and 3 is going to be appended into our resulting list, right? And then we're done with this. Then we go back up to this 1 and 2. And then we already went through all possible stuff because we added the 3 and then we passed it on, right? So we're done with this basically. So yeah, we're basically done with all this. But technically what happens is that we remove the 3. But who really cares if we remove the 3 at the end? Because what really matters is that once we're done with this 1 and 2, we already did our recursion, right? So what we do is we remove the 2. We remove it, which was the 2. And then now our possible right now is that we already did 1 and 2. So now we do 3. So now we remove the 2 because that was it. That was the possible that we did. And then we add the 3. So we append the 3, go through that first search again. And then we go through all the possibilities. So we have 1 and 3, but we don't have 2. So we add 2. And then we call that for search on 1, 3, and 2, and hits this. And then we just return our 1, 3, 2. And then from there, what happens is that once we're done with 1 completely, because 1 already did all this. 1 already did 1 and 3, but in this case, once we start at 1, we were only at 1, right? We were only just at 1. Because remember when we started with empty, and then we added 1 into that, and then we went into 1 and did all this recursion, right? So now we say pop 1, go back and do all the possibilities for 2, and then do all that we did for 2. So 2, oops, 2. So did all that for 2, and yeah, and stuff like that, and then 3, and then bum bum bum. So that's kind of what's happening. Just one recursion. No, I mean just like one. We just do one set of permutation for 1, and then yeah. And then that's it. So to make this into code, right? So return res. So to turn this into code, res is gonna be the same. That first search, we just gotta code that up. Can you guys see what I'm coding up? Okay, you guys can see. Okay, cool. I need to take. Oh my god, I need to drink some water. My like mine is in overdrive right now, and my throat is so dry. When I'm back, I'm out of breath. I need to pace myself. So we did that first search, and we're gonna pass on. I'm gonna say perm instead of cur, because that makes more sense. Our permutation, and then we have to do our base case. So if we call that first search with cur, when the length of perm is equal to the length of our input, which is num. So to fix this, open the Alexa app and re-enable the skill. What? Alright, anyways, I think I'm getting hacked in my house. That's fine. Getting a job is more important. So if the length of our permutation that we passed in is equal to the length of our input, then that means that we have a good permutation. So we found a permutation. So what needs to be done is we need to append this permutation into our resulting list. So we say res dot append copy of our permutation, right? And then if that's not the oh yeah, then we also have to return. If that's not the case, we're gonna go through our just regular backtracking with the pattern. So append this, then go further, and then once you go further and got all the results from that, remove it. So so for oops, so for num and nums, right? So for all the possibilities in our input are from our input. So if num not in perm. So if it is possible, so by saying if it's not in our permutation, that means that it is possible to add it, right? So if num not in perm, then perm dot append num. Then we call that first search on our perm. And then from that, once we got that permutation, we need to say, oh my god, I think I'm about to pass out. I need to get some more breathing. You know, this might be a problem in real interviews where I might actually pass out. That'd be actually kind of funny if I was like interviewing with like a company that I really liked, then I just pass out because I'm talking too much. That'd be kind of funny, and then I failed the interview. But anyways, so and then once we append it and do the and then we get the permutation, I'm gonna say perm.pop, whatever we just added into it. And then oh my god. And um then yeah. Then then we just basically did where is it? They basically did all this, then we pop the two, move on to the three, then get the permutation. And then once we did all the possibilities of one and two and three, we're back. We're gonna pop one, then go to two, and then do all that again, right? And then what happens after that first search is completed, we're going to return res. But in order to run our that first search, we need to call that first search with an empty list first, and then that should work. So run, accepted, submit. Let's fucking go. So yeah, I do understand this problem now. I kind of didn't really get it because I was on the case where I would say, okay, so we did. I didn't keep track of this for loop. So what I did is that okay, so I'm done with one and two and three. So now I have to pop 2, then go to 3 from here. But that's not the case because I already got 3. I said, okay, so from here, we already have 1 and 2, so we have to append 3, right? So I didn't think about going back here to append a 3. I thought about just popping the 2 here and then adding the 3 as its own tree, right? As right here. But that wouldn't make sense to me, so I was stuck on that for like an hour until I had to like carefully go back in my steps and read the code and actually understand it. So yeah. So for complexities, for space, I don't know. Is that like O of n factorial? I don't know. I know it's something factorial because this is a factorial, right? Or like 3, like n factorial is just basically n minus 1 factorial times n factorial. Just like stuff like that. I don't know. So yeah. Like I'm out of breath. I don't know the complexities. I don't really care about it either way. So yeah, that's the video.